After the setup is complete, we can run the FullMonte simulation by clicking the link in the next steps or go to the simulation tab on the left. As a first step, we need to specify the mesh file to run the simulation. We can do this by selecting from the drop-down list of mesh files that you have used to run simulation before, or we can upload a new mesh file to run the simulation. For this demo, I will be choosing the Colin 27 mesh. Next, we need to specify the unit of the mesh. The mesh I'm using is in millimeters, so I will choose that accordingly. Next, I will need to specify the types of energies to record to output. For this demo, I will only recording the energy absorbed by the mesh and energy leaving the mesh. If you wish to record energies entering or exiting the internal boundaries of the mesh, you will need to supply the ID of the region that you wish to record. The packet count refers to the number of photons that will be launched in the simulation. A larger number of photons will give a better simulation accuracy, but it will also linearly increase the simulation execution time. For this demo, I will keep the default value, which is 1 million photons. And I will use 10 joules as the total energy of the simulation. Next, we need to choose the optical properties of the materials in the mesh. Please specify the material properties in the order that matches the region ID of the supplied mesh and in units that matches the supplied mesh. For this demo, I will be using the preset materials from the database, but these values can be easily changed to match different meshes and configurations, and you can always specify new materials if they are not in the preset database. Going to the next step, we can specify the light source and their locations. For this demo, I will use one point source with the x coordinate of 127 millimeters, y coordinate of 48 millimeters, and z coordinate of 90 millimeters. If you don't know where to put your light sources, you can use the 3D interactive visualizer to help you position the light source. Next, the website will ask you to confirm the parameters that you just specified. On the bottom of this page, under Advanced Options, you will be able to download the auto-generated script, modify, and upload it again. Please do not change the relative file path inside the script, as those are used inside the server. This functionality provides a finer grain control of the simulation for more advanced users. Click the Confirm and Submit button will launch the simulation. The web page will refresh itself every 5 seconds to show the current progress of the simulation, and it will automatically redirect the user when the simulation is finished. Now the simulation is finished, and the output of the simulation will be shown. This is very useful, especially when the simulation has failed. As a next step, you will be able to visualize the output of the simulation.